Now we're going to get into solving what are called proportions. In order to create a proportion, you need ratios. A ratio is essentially a fraction. It's a comparison of two numbers. A proportion is when two ratios are equal to each other. An example of a proportion you should be familiar with is 2/3 equals 6/9. Of course, 2/3 is the simplified version of that fraction. So our essential question today is, how do we apply the golden rule of algebra? Remember, that's whatever you do to one side of the equation, you do to the other, to solving proportions. When we look at our first proportion, we have a variable in the numerator, and our variable is being divided by 12. To cancel division, we multiply. I'll multiply both sides by 12, golden rule. On the right-hand side, it cancels, leaving me with m, which is what we want. On the right-hand side, I'm going to simplify. 12 and 8 both have a common factor of 4. I'm going to rewrite this so my simplifying is a little bit easier to see. Dividing 12 by 4, I get 3. Dividing 8 by 4, I get 2. Now I can multiply my 3 by 7 over 2 to get the simplified version of my answer. What we just saw was the most basic form of a proportion. We can also see some slightly more complicated forms. In this case, we have two variables and we have a variable with some other stuff going on. So let's see how this works. We're still going to start with that golden rule of algebra. We've got division on both sides, so I want to cancel my division. We'll end up canceling them both. You can choose either one to start with. I'm going to get my n alone, so I'm going to multiply both sides by 5. Distributing that 5 through the entire numerator, I get 10n plus 20 all over 6. So now I'm going to cancel that division by 6 by multiplying both sides. That leaves me with 6n equals 10n plus 20. So now to solve, typically I would subtract the 6n, but that wouldn't leave me with anything on the left-hand side. So I'm going to subtract 10n instead. Careful for your negative signs. We do have a negative for n equaling 20. So to solve for n, we'll divide both sides by negative 4. n equals negative 5. Finally, we'll learn how to solve with a variable in the denominator. The golden rule applies to this one as well. We don't want that variable in the denominator. So what I'm going to do is flip both sides. Remember, whatever you do to one side, you do to the other. That will keep our equation equal. Then I can cancel my division by multiplying both sides by 3. I get g all alone on the left-hand side. On the right-hand side, I'm going to cancel my 3 into the 9, and I get g equals 10/3. So remember, I divided my 3 by 3, which canceled, and I divided my 9 by 3, which gave me a 3. That's how I got 10/3. Our final example, of course, we saved the best for last, the most complicated one. Our variables are both in the denominator, so I'm going to start by flipping both sides again, get those variables out of the denominator. And then I can solve it the same way I solved that example 2. I have to cancel both of my denominators. I'll cancel my negative 2 first, distributing that through to the entire numerator on the right-hand side. I get negative 8d minus 2, still all over that negative 3. Now I'm going to cancel that negative 3 by multiplying both sides. Remember, the reason I'm doing that is to cancel the division. So in this case, on the right-hand side, I'm not doing any multiplication, I'm just canceling. Distributing that negative 3 on the left-hand side and leaving me with that negative 8d minus 2 on the right-hand side. Now I have a variable on both sides, so I want to pick the variable with the smaller coefficient to cancel. The smaller coefficient is negative 8, so I'm going to add 8d to both sides, giving me 5d minus 27 equals negative 2. Don't lose your negative sign. Adding 27 to both sides, we get 5d equals 25. And dividing both sides by 5 to solve for d, we get 5. And you have 2 U-Try questions.